So, hello students. In today's lecture, we will focus on the seasonal variation. As in the last video, we talked about the four components TCSI: trend, cyclical variation, seasonal variation, and irregularity. Now, we will focus on seasonal variation. So, what is seasonal variation? Seasonal variation of data, any data. Suppose it is a sales data. Seasonal variation will tell us that at which point of the year there is a high in sales and at which point of the year there is a low in the sales, low sales or constant. So whatever may be the case. So this is about seasonal. So one example we can take about the sales of AC. Suppose a company like Samsung who are manufacturing AC, for them it is a matter of concern that to know at what part of the year the sales is increasing. So what these companies will do, they will track the 5-year data, which is a time series data, and every year they will try to analyze that whether there is any seasonality within the data. So for them seasonality is a very important factor. Now what seasonality affects is that it affects the smoothness of the data. So there is ups and downs, there are peaks in the data. So seasonal variations are fluctuations that coincide with certain seasons and are repeated year after year. So every year in the month of May or June, any say AC selling company in India will see that in the month of May and June their sales is increasing. We also understand the seasonal fluctuation. It helps for planning sufficient goods and material on hand to meet varying seasonal demand. So what we will study is that we'll try to have a seasonal index. We'll try to construct a index which is called a seasonal index. So any index, we understand that it's a number. Any index is a number usually expressed in percent that expresses the relative value of a season with respect to the average of the year. Suppose the average sales of the year is, we take 100%, and we say that suppose for the month of January the sales is 95%, and for the month of February the sales is 105%. So in terms of index, if we talk, in the month of January 5% less than the year average sales is there, and in the month of February 5% above the 100% sales is done. So any index, we take 100 as base, 100%, or we take 1 as base. Now here in this topic we'll study in detail the ratio to moving average method. Already I have explained the what is moving average method. Now let us understand the ratio to moving average method. So what is done, fundamentally what is done is that in this method we eliminate the component of T, C and I. So we are left out with seasonal index. So any data, first of all from the data what we'll do, part 1, we will create a seasonal index. So I will discuss in detail taking our data about how to create this index. But before that, we will let us understand what are the steps. So first step will be to construct an index with the help of moving average method, rather ratio to moving average method, step 1. And in the step 2, we will, with this index, we will deseasonalize the data. So these are the broader 2 steps. Now how to construct an index, I will show you with the data. So just if you go through the slide, it's a seasonal index. This table shows quarterly sales. So if you see in the row, I have taken the years 2001, 2, 3, 4, 5, 6. So these are the year, and in the column I have taken the winter, spring, summer, fall, and these are the sales. in $1,000,000 sales. So $6.7 million is the sales in 2000 year in the winter. That means I have divided my data into quarter. First of all year and then year into quarter. So this is my format of data. So we will take this data to another slide and we will stepwise we will understand that what are the methods we are following. So first step, we organize the time series data in column form. So if you see this this data, so in the year 2001 the quarterly winter sales is 6.7, in the spring the sales is 4.6, in the summer it is 10, and so on. So we have written our data, whatever in the table from the tabular form, we have written our data in this column form. So that is our step 1. Step 2, we will compute the 4-quarter moving total. That means first of all, you see we have taken 6.7, 4.6, 10, 12. So we have taken the total of the first 4 quarters of 2001 and we have constructed a total. We have written the total here. Similarly, for all the next, we will take 4.6, 10, 12.7, 6.5. So next 4 we will take and we will write in the, but see we write, whenever there are 4 data, then we cannot write in the second quarter or in the third quarter. We have written in between the second and third quarter. So 34 I have not written in the second spring or in the summer. I have written in between because we are having, this is the result that we generally take 3 months, but here my data is in the quarter form. So what do I do? So in this way we have made the total in the second column. In the third column, what we do is that we compute the 4-quarter moving average. And so in step 3, you can see here the column 3, designated 3. Here what we have done, we have taken the average, that means 34 we have divided by 4 because we have taken 4-quarter data, that is 8.5. So 8.5, so we have taken the average. We have taken the average of all these data. And in the 4th column, step 4, we computed the centered moving average by getting the average of 2 4-quarter moving average. That means this 2 data, we will take the average and we will write in the 3rd row. That means in the summer. So in the summer, the average moving average sales is 8.475. In this way, we will take the average and we will write in the 4th, the column depicted 4. And finally, we will take the specific. So we compute the ratio by dividing actual sales by the centered moving average. So if we divide the actual sales by this moving average, we will get the specific seasonal index, which is in the 2001 we are getting 1.18. So we have got an index in the, for the quarter of summer it is 1.18. So these are the calculations. So we have got the index for, so now very few things to observe in this sheet is that we will not get any index for the first winter and the spring of 2001. So we'll start from summer. Now what I will do is that we'll convert this all the seasonal index into the form of again a tabular format. We'll take this in a tabular format. So 2001, I have written here summer, the index was, if you remember, it is 1.18. In the fall it was 1.5, the index. So we will write all the index year wise and quarter wise. Next, so next we will take the mean of all this. Suppose in the winter we have 1, 2, 3, 4, 5 readings, 5 indexes. So we'll divide it by 5 and we'll take the mean. So you have calculated the mean for winter. So if you see the mean for winter is 0.767. In this way we will calculate for spring, which is 0.576. In the summer we will calculate it is 1.14, and fall it is 1.52. Now see, if we add all the means, we have got 4 mean indexes for the 4 quarters. So ideally it should add up to 4.00, but in our case it is 4.009. So here comes the concept of correction factor. So we'll use a correction factor. So what will be our correction factor? It is 4. Ideally what it was, the sum was supposed to be 4, but now it is, in our case it has come 4.009. So what will be our correction factor? It is 4.00 by 4.009. That is, it is 0.997755. So we have got a correction factor. So now with this correction factor, we will multiply all the means to get what is called, you can see here, the adjusted index. So if we multiply 0.67 with our correction factor, it is 0.765. Similarly, if we multiply 0.576 by our correction factor, it is 0.575, and so on. Now if you see, all the 4 add up to 4. So we have finally arrived at our index. That is, for winter it is 76.5 or 0.765. For spring it is 57.5. For summer it is 114.1. For fall it is 151.9. So we have got index for my 4 quarter, that is winter, spring, summer, fall. So we have calculated the index. Now what we saw, that is our first step. That was our first step to construct the index. Now we have to deseasonalize the data. So now let us deseasonalize it. So what will be the formula? Deseasonalized sales is equal to sales divided by seasonal index. So whatever index we have calculated, the original sales figure that we had, we will divide it by seasonal index to get the deseasonalized sales. So we will make our data free from any seasonal index. So you can see here, column 1, the original, I have taken the original sales. In column 2, I have taken all the indexes, seasonal indexes, and in the column 3, we divide the sales. Say for the 2000 year winter, it is 6.7 divided by 0.765. So the deseasonalized sales is 8.76. So these, if you see the third column, we have got all the deseasonalized sales. So now, see, if we see the data in the column 1, we are having sales, the original data, and in the column 3, we are having the deseasonalized sales. Now, if we plot these two data, you will understand what is our effect. So this blue line, if you see the blue line, this was our original data which had so much of fluctuation, sales fluctuation. But this red data is our smoothened data with the help of moving average, ratio to moving average, and you can see that this is a very smooth data where the seasonality has been eliminated. So the data is now free of any seasonal index. So the data contains only the T, C and I, that is trend, cyclical and irregular. So that's all about time series and index.